Hello everyone, welcome to my channel. This is our third video on solid principle. In this video we will learn about OCP principle, that is open closed principle. So the second letter of solid, that is O, because it's SOLID. So that O stands for OCP. And let's also we'll understand how it can help us to create better software design or to write better code. So what does this OCP tells? Any software entity, that means it's whether it's class, module or functions, those should be open for extension but closed for modification. So open for extension and closed for modification. What does it mean by, and why it is open for extension but closed for modification? So let's say first understand that OCP stands for open for extension, closed for modification. But why? Why means it allows different implementation based on the abstraction. So here the OCP actually tells about the abstraction, or it tells about how we can abstract the implementation. So OCP is for that abstraction only. How we can achieve? By polymorphing inheritance, plugins or adapters. So here the key thing is the inheritance. By using inheritance we can achieve the OCP. So it helps or to extend the behavior of existing system without modifying it. Let's say even we will find there are several plugins built for Eclipse or our IntelliJ IDE, Visual Studio. Whether those plugins are actually making any change to the Visual Studio codebase? No, they don't make the change in the actual codebase. That means the Visual Studio codebase will be with Microsoft, but the plugin can be with some other, or it can be with any developer. The license can differ, or also we can say the implementation also doesn't depend upon the Visual Studio implementation. Okay, means it will not make any change to the Visual Studio implementation, but it is an add-on. So for that type of development, this OCP helps. And also it reduces the complexity and increases the decreases the development life cycle. Reason that the less impact to the existing system, then there will be less changes or less issues. In that aspects OCP helps. So what is the benefit? We can say let's we have already written a class or function and it is working fine. Now we want to give some additional features on top of that class or method, which can either completely change the behavior or it can extend the behavior. In those cases, due to by following the OCP, we are saying that we will not make change in that class. That means the class can be or is stored in library, or it's compiled, while it is open for any new class to use it as a parent and add the new features. So in that case we can say the the owner can be in different library, different package, or can be with different organization as well, while the extension pair can be with someone else, like Visual Studio. That code base or that ownership is with different organization, and the plugins ownership is with respective developers or organizations. So both are completely different, and they both don't know each other code base, but still they can work together. So when a descendant class is defined, there is no need to change the original or to disturb its clients. That is the benefit that OCP gives us. Now let's take the example. In our normal use case, we can say in almost all applications we have login and logout scenarios. So let's say initially we got one requirement where we need to only support two methods, that is login and logout. Then the requirement increased. We need to where we got that we need to allow Google login, Facebook login, or OTP based login, even email based login. So there are different type of use cases we find it's increased. But initially whatever our authentication mechanism we had, or login logout, that was very basic. So in that case I have created one class like authentication, like it is shown in the example. So that authentication class have login, different methods. One is login email, logout email, login Google, logout Google. Similarly, login and logout of Facebook, login and logout of OTP. So it had all these methods. But now let's say another type of login again I need to support. In that case, again I need to write or add few more methods to this authentication class. That means my for any type of a requirement change or extension, especially for extension, I am touching this authentication class again and again. That means this authentication class cannot be with the library, and I cannot develop the feature independent. Always I need to make the change in the library, and there are lots of times it's very difficult that to change the library. And second thing is that it might break my already tested feature if we change to the actual class. So instead of that, I have changed the code like this, where my that authentication module, I have created one interface, that is I authentication, and one base class authentication, then followed by email authentication, Facebook authentication, and so on. So this is the interface that I had created, I authentication, which are two methods, login and logout. As interface doesn't have any implementation, it's only signature. And the authentication class, it implements the I authentication. That means the login and logout method implementation I have written inside the authentication class, and already this is tested. Let's say it is working fine. As my product people told me that I need to support the Google authentication or Google login, so here I have created the Google authentication, which extends the authentication class. That means all the features of authentication class will be available here. And here I got the requirement that here we need to support login and logout of Google instead of using the old or existing authentication flow. That means I can write the new implementation here. Also as this is the inheritance, that Google authentication class is the inheritance of authentication class. That means the all the functionality of the authentication class will be available to the Google authentication class. Similarly, as we have got that we need to support the OTP authentication. Let's say in that case only login needs to be supported, and logout will be basic authentication logout, like clearing the cache and nothing else. In that case, no need to implement that, because the authentication class had the logout method, and it will be available to the OTP authentication class as it's the child class. So in this case, no need. We can say all the functionality or all the implementation of authentication class is already available to the OTP authentication class. In this way, we are saying that if let's say in future, or we got a in future we got a requirement where we need to completely remove the authentication class or authentication implementation and use only OTP authentication, then it's also easier. Because that OTP authentication already it extends the authentication, and it can either use the behavior of authentication class, or it can override the behavior. So that means this why we are creating these classes and how it benefited. One is that let's say in our example, authentication, first we got requirement for a basic authentication, and all the flow is working fine, it is already tested, that's fine. Now we have added Google authentication, and it didn't make any change to the original authentication class, and let's say it also worked fine, so it can be kept as a library, it is stable now. Then when the next requirement came for OTP authentication, that time we are saying, or we are giving guarantee that authentication and Google authentication, they will work for sure, but OTP authentication changes will not impact the other authentications, so that impact will be reduced, or the risk will be reduced. That is the benefit that OCP provides. Otherwise, if we see from our first authentication class, the example where we have shown that list of all the methods, that is single responsibility, single task. I have created lots of methods. Each method does the task, but for any change, always I had to make change in that authentication class. That means it's not open. Means I can say that class was always open for modification, but that should not be there. The class should be closed for modification, but open for extension. This is the open for extension. Means inheritance we are allowing. Thank you.